Hello there. So I thought I was recording my lesson while I was teaching it, and then I realized I wasn't. So now I'm going to kind of make an abridged version of this lesson. All this buildup has been to get to this understanding of Taylor and Maclaurin series, and in general, a Taylor series is just a power series, but it has derivatives at all orders. Basically, that means it's differentiable everywhere, and that's why we deal with sine and cosine and e to the x and functions that have derivative values at all locations. And then you are to memorize the expansions for e to the x, sine of x, cosine of x, and the other one is 1 over 1 minus x. So these are the four that we have to have down cold. We have to know these without having to actually go through and derive the expansion. So this lesson is really just some AP questions that they can ask of you. So just kind of applications of Taylor's series, some good ones. So I'm going to go through these and give you some advice. But it says the Maclaurin series for a function f is given as follows. Which of the following is an expression for f of x? Now, this is where knowing these stone cold can help you eliminate some of these things. What I mean by that is this, like we know sine of x, or we should, sine of x, if we expanded it, would be x minus x cubed over 3 factorial plus x to the 5th over 5 factorial minus etc. My point is that the signs alternate when we expand sine of x, and if I notice, the given problem has all positive terms. So it's not sine of x, I know that, can eliminate. Negative sine of x, this is where kind of the fun begins, us being able to take these ones that we have memorized and using algebraic operations to manipulate. For instance, if I wanted to figure out what negative sine of x is, well, negative sine of x would mean I just flip all the signs on the other side of the equal sign. You're multiplying both sides of the equation by -1. Again, the signs alternate, so it's not that one. Cross that one out. Okay, the other two, now I notice I have e to the x and e to the negative x. Well, I don't know which one this is yet, so I'm going to list out e to the x. E to the x equals 1 plus x squared over 2 plus x cubed over 6 plus ... Okay, so this is what I mean by we can take these ones that we know, and if I want to figure out what e to the negative x is, well, all that means is I take all these x's here and I replace them all with negative x instead. And what that looks like is this. I would have 1, and if I replace x with negative x, it would become minus x. Now here's where you need to be careful. If I replace this x right here with negative x and then square it, it's still going to be positive, because you're going to be essentially squaring -1 and squaring x, so that term's going to stay the exact same. When you plug in negative x for x cubed, well, that's going to be negative and then x cubed over 6. So sometimes you're going to be asked to take, these expansions and substitute something in for all the x's. What we can also do is take these things and add them together, subtract them. Sometimes you need to multiply them. Look at my answer choices. I'm trying to figure out e to the x minus e to the negative x. Imagine I just subtract these two equations down like I'm doing a system. So e to the x minus e to the negative x. Okay, so imagine I'm just subtracting down term by term. So 1 minus 1, that first term's gone. X minus negative x becomes 2x. And already I can see that the answer is not D, because the first term here is x and the first term of this is 2x. So it's going to be half of that. So once you get here, just pick your answer. But to keep going a little bit more, if I subtract these x squared terms, those are gone. Subtract these, so I'm going to get 2x cubed over 6, or x cubed, what am I saying? Not 2x cubed, x cubed over 6. What did I do here? No, that's right. X cubed over 3. I was confused because I was like, that's not the answer. But the answer is we would take half of this. And so b. Okay, so that's one thing we can do. We can plug things in for x once we have our series memorized. We can combine certain series expansions, things like that. The next thing is understanding what the general term is of these. So this says, which of the following is the Maclaurin series for x cosine 2x? Now these look scary off the bat, but I'm going to give you some advice and things that help me. So what I would first figure out is, what is x cosine 2x? So to start, I would write out what is cosine of x. Let's start there. So cosine of x is 1 minus x squared over 2 factorial plus x to the 4th over 4 factorial minus x to the 6th over 6 factorial plus dot, dot, dot. So again, that's just one we have to have down pat. Well, then we can figure out what cosine of 2x is. I can figure out what cosine of 2x is. So imagine I take all these x's over here and I replace them with 2x instead. So for instance, I would have 2x squared. So imagine in parentheses you have 2x squared and then you distribute the 2. So you would end up, well, this first term is going to stay 1, but then it's going to be minus, and it's going to be 2 squared x squared. So what I'm saying is this. If you replace x with 2x and square it, yeah, you would get 4x squared. The reason I write it like this, I want you to look at all the answer choices and notice how we're trying to figure out some patterns here. So I don't want to simplify these things. I want to be able to look at what I have term by term over here and figure out what does that match with over here on the left. That's why I just leave it like this. Then the next one, if I replace x with 2x, I would get 2 to the 4th, x to the 4th over 4 factorial. And I can do the next one as well. But I'm really after x cosine 2x. So now imagine I take that line and I multiply both sides of this equation by x. So I'm going to multiply every term on the right side by x. So I would have x minus 2 squared. Well, if I multiply x squared by x, I get x cubed over 2 factorial plus 2 to the 4th, and now it's going to be x to the 5th over 4 factorial. And now I start to come back over here at my choices, and let's see if we can figure out what the answer is. Well, I notice they all have negative 1 to the n, so that's going to be irrelevant. That just means the terms are alternating. They're all divided by 2n factorial, so I'm not going to look at the bottoms. So what I notice is the 2's here. Notice that in our expansion, 2 is being raised to a power. Well, I can eliminate then a and d because look at a, it's always 2 to the 1st. That never changes, and obviously 2 does get raised to different powers. So I can eliminate a and d because 2 has no exponent. Then I'm looking at the x's. So look at the differences here. Notice that the power on the x is always 1 more than the power on the 2. So 2n plus 1 is 1 more than 2n. We got our answer. All right, lastly, this one's really cool. This might be my favorite kind of application. So the question says, which expression below represents the first 5 terms of the Maclaurin approximation of the area of the region bounded by e to the 3x squared and the x-axis from 0 to 1? Well, this is integration. When they say find the area under this curve bounded by the x-axis, that's us integrating e to the 3x squared from 0 to 1. Like, that's the question. But here's the problem with integration. We can pretty much differentiate anything in the world. We can't integrate everything in the world. I can't integrate this, is my point. I cannot integrate e to the 3x squared. I could try u substitution, but if u is 3x squared, du is 6x, and there's no other x. So here's where these expansions get really handy. What I'm going to do is figure out what is a polynomial expression that I can replace for e to the 3x squared and then integrate those terms instead. That's what I'm after. So let's start with just what e to the x is. E to the x is 1 plus x squared over 2 So I made this mistake in class. I didn't look at my answer choices very carefully, and I saw that we had to go out to 5 terms, and so I expanded this to 5 terms, and then it just took a lot longer. Well, if you notice, we really only have to go to 3 terms because all 4 choices are the same to start with. Then they differ here. But then notice, if the second term is 1, the third term differs. If the second term is 3, the third term still differs. So we only need 3 terms that we're going to deal with instead of 5. That's going to make the math a whole lot easier. But I'm trying to figure out a replacement for e to the 3x squared. So that means if I want e to the 3x squared, replace any x in this first line with 3x squared instead. So 1 plus, and then 3x squared. And then I'm going to replace x with 3x squared. So that would look like 3x squared squared, and so that would be 9x to the 4th over 2. So there's my third term. So what this means instead of integrating e to the 3x squared, we're going to integrate this polynomial instead to get an approximation. So now imagine I integrate this thing right here. We're going to integrate this and then plug in 1 and plug in 0 and match it up to our terms over here. So if I integrate 1, I get x. If I integrate 3x squared, that's going to be x cubed. And this is going to be x to the 5th divided by 5, so 9/10 x to the 5th. From 0 to 1. And now I just plug 1 in for all these x's, and I can match it up to my terms over here. I would get 1 plus 1 plus 9/10. So that's got to be A. So that's a really cool application to these things. So what's on the Canvas page? There is an FRQ that I would highly suggest you try and get back to me if it doesn't make sense. And then there's also an assignment. And then there's an e-learning page with a couple more FRQs over these Taylor things. You can find the rubrics. You can find the video explanations. But let me know if you have any questions.